Alright, this is the first video where we're looking at the lab properties of Group 1, the alkali metals. What we need to do is fill in these valence core diagrams below for lithium, sodium, and potassium. Alright, so if you recall from our work in class and even past videos, fold my periodic table one more time, you'll notice that lithium, sodium, and potassium are all in group 1. So remember, the group number is going to tell you the number of valence electrons and the core charge. So each of these guys here will have a core charge of +1, so you want to fill that in, +1, +1. And oxygen, which is over here, is in group 6. So its core charge and valence electrons is 6. So for oxygen, which is right here, we're going to write +6. So you can see here there's a big difference between the core charge of oxygen compared to the metals we're actually going to be using in the reaction. Okay, we'll also want to fill a number of valence electrons. Again, lithium and sodium and potassium are in group 1, so there's 6 valence electrons. So we'll just color in one spot for each of these elements, and we don't need to do that for water because we've essentially shown the valence electrons for our hydrogens and the oxygen in that particular molecule. What matters most, though, is well, metals tend to lose electrons very easily, and so the lithium and sodium and potassium are going to lose their electrons to the oxygen in the chemical reaction, and that has everything to do with the difference in core charge between those particular guys. Okay, so we've got our diagrams filled out. So what we can do now is flip to the other side of our sheet. Okay, and what we want to do is write this question down. Which alkali metal is most likely to lose electrons to water in a chemical reaction? Now I got that on the front side of my sheet, in fact, right here. Okay, what's the question? So this question right here, essentially what you're doing is rewriting it on the opposite side of our sheet, where it says focus question. Write the question that you're trying to answer. So rewrite that there, and you can probably pause the video right now so to make sure that you're able to do that. Okay, and we're going to continue here, and what we want to do is also write a prediction and write an explanation. And so which alkali metal will be the most reactive with water? Well, what we want to do is look at the valence electron core charge diagrams we did, and you'll notice that the core charge is the same, the valence electron is the same, but the actual size of the elements is not the same. Lithium is the smallest, potassium is the biggest. And when it comes to metals, the elements that are the largest in size tend to lose electrons the most easily. So it's going to be potassium is, or we should say will be most reactive. Over here we're supposed to explain our prediction. So what we want to do is refer to diagrams on the front, because we've already completed those. We don't need to do it again. And so all 3 elements have the same core charge and number of valence electrons. Okay, so we want to make note of that. Potassium is largest and will have have the least strongest, that's probably not the best way to say that, but has the least strongest hold on its valence electron. Okay, just think of it this way: if you have two magnets, I don't have two magnets with me, but if they're really close to one another, that pull of attraction is very strong. If the magnets are further apart, that pull is actually much less strong. So that's what's actually happening over here, right? The distance right here is small, and that attraction is fairly strong. If you're comparing these metals with one another, this distance here is much larger, and that means the attraction between these two guys is much less, and this electron is therefore weakly held compared to lithium and sodium, and it's going to be more easily stolen and attracted to the core charge of +6 that's found in the oxygen.